So to get your whole genome, at least for me, was both overwhelming and underwhelming. Overwhelming in the sense that it's just a massive amount of information. So my whole genome was sequenced 26 times over. We do it in a very redundant way to make sure that it's accurate. So what that meant was, when it was all said and done, there were 80 billion bases that lived on a server. And 80 billion of anything is difficult to contemplate. And it's even more difficult to contemplate when you know that some fraction of the stuff of those 80 billion things are directly meaningful to your life and to your ancestry and to your health. But by and large, it is a tiny fraction, and even that tiny fraction has uncertainty attached to it. And so in that sense, it's underwhelming, because it is an awesome technical achievement to sequence a human genome. Although, as I sit here in 2010, probably most people in the field would say, well, it's not really such an awesome technical achievement anymore. But we know so little about how to interpret the information. Now, that said, I would want to emphasize that having a genome is not useless. And I think a lot of people, particularly a lot of doctors, think that it's just useless and there's no point, and we're not ready. And I would concede that it's not useful for everyone, and no one should be forced to do it. But I think the time has come that we need to be open to it, and we need to start facing that challenge of interpreting the information, of really understanding the code. Well, probably the most powerful example of that is height. So height is a trait that is highly heritable. So if you look at parents, you can get a pretty good idea of how tall their children will be. Obviously, we know diet has something to do with it, and I'm sure there are other environmental factors. But when we go and look for genes that contribute to height, we find thousands and thousands of them, each with a tiny effect. So what the height example shows is, even in those cases where we think our traits are mostly determined by genes, they can be determined by genes in a way that remains utterly mystifying to us. The other thing is, height is exceptional when we think about traits that define what it is to be human and to live and to die. So when you think about common diseases like heart disease, most forms of cancer, that sort of thing, the formula seems to be genes plus environment. And by environment, I'm speaking very broadly: what you eat, how you live, where you live, how much you exercise, Did your parents give you enough love? That sort of thing. And so all of those things interact with our DNA and the proteins that it codes for in ways that we really don't understand. But we know that they're very important.